Hi, this is Phoebe, and I'll be presenting our final GIS project. For our project, we chose to study food deserts in Metro Atlanta. Our group members are Emma Malcolm, Emily Mitchell, myself, Phoebe Graham, and Sarah Pierce. In case you are unfamiliar, food deserts are areas in which residents do not have access to fresh food, usually grocery stores, within a reasonable distance from their homes. Food deserts are distinguished by an abundance of fast food restaurants and an absence of grocery stores. When analyzing food deserts, it's important to look at the intersection of income, race, access to public transportation, and distance from a grocery store. We are defining food deserts as anything greater than a 2-mile radius to public transportation. For our project, we decided to focus on the 12 counties in Metro Atlanta. We wanted to study a large city in Georgia that would be familiar to us and other students. Atlanta was a good choice for its large population and diversity. Atlanta is ever growing and one of the most economically successful areas in the Southeast. This makes it interesting to study the intersections of income, race, and location. Our research question is what correlations exist between race, income, and food deserts? We anticipate that food deserts will exist more frequently in low-income communities of color. We predict Clayton County and Paulding County to have the most food deserts due to their low per capita income compared with other counties. We used the Atlanta Regional Commission's data for our project. We first obtained data on the location of grocery stores in the Metro Atlanta area in 2020. Then we found data sets showing race, ethnicities, and income distributions in the Metro Atlanta area, also from 2020. Our final data set showed the Atlanta public transportation routes. This data allowed us to make a map comparing each item we chose to define food deserts. For our methodology, we started by importing our 4 shapefiles. From those 4, we selected counties with grocery stores and exported them into a new shapefile. We used the Euclidean distance tool to show what areas are far from transit stops. The coordinate system of transit stops, transit routes, and grocery stores didn't match, so we used the project tool to change each shapefile's coordinate system. The dist from stop 3 file symbology was changed to have defined interval classification in increments of 1 mile from 0 to 35 miles. Next, the clip tool was used on dist from stop 3 with new counties as the export boundaries. The same step was repeated on dist store with new counties as the export boundaries. We reclassified dist from stop 3 and dist store so the new value associated with the old ranges are 1, 2, 3, etc. We then used conversion point to make every grocery store represented by a cell value of 1. We then used the spatial analysis tool near, with the stores as the input feature and the transit stop as the near feature. We then used the near dist column from the attribute table to show stores closest to public transportation. The symbology was changed from the store distance and the transit stop distance to appear gray when a feature was within 2 miles of a store or a transit stop. This layer was made transparent to show the race and income areas underneath. We added the 2-mile buffer layers for grocery stores and transit stops into one layer. The output was reclassified so the areas accessible to public transportation or grocery stores had a cell value of 1 and all other areas had no data. We added the income data and used the Select by Attributes tool. We selected rows for our specific Atlanta counties. Next, the race data was added. We wanted to symbolize by non-white. This was not already available, so we added a field and calculated from the data using the highlighted formula. Next, we joined the GeoID from the race attributes table to the GeoID 10 in the income table. We selected keep only matching records to add all of the race data into the income table. We then symbolized using a race field rather than an income field. Here are our 2 final maps. Map 1 on the left shows the geospatial proximity of public transit stops to grocery stores, overlaying the per capita income distribution in the Metro Atlanta region. In map 1, we can see the majority of food deserts occur in regions where there is a low per capita income. This means that many of the low-income regions of Metro Atlanta do not have public transit stops near the grocery stores. In fact, we can see many of these lower-income regions, which are more rural than the heart of the city, do not have grocery stores within even a 7-mile radius of public transit stops. Map 2 also shows the geospatial proximity of public transit to grocery stores. This map depicts the percentage of non-white residents across the Metro Atlanta region. This symbolization of data allows us to gain a better understanding of how access to grocery stores may be correlated to race. For map 2, we concluded the majority of food deserts occur in rural areas that are over 50% white. This goes against our initial assumption that the majority of non-white communities would be subject to more intense food insecurity. Overall, our findings show that food deserts are more common farther away from the heart of Atlanta. The areas with the most food deserts are Cherokee, Cobb, Douglas, Coweta, and Paulding County. This is not surprising given their proximity to the Atlanta area. Our findings show that the regions of Metro Atlanta that are more rural, have a lower per capita income, and contain a majority of white people have the most food deserts. This conclusion contradicts our initial research, where we found that Black and Hispanic families are twice as likely as their white counterparts to face food insecurities. While our maps don't support the current research that say that marginalized families are more likely to experience food insecurity, our research does show that lower income families in Atlanta are more likely to live in food deserts. Our maps may contradict the current research because there are more factors than public transportation access that can contribute to food insecurity.